All right, so today we're going to talk about identifying proportional relationships with a graph. So another way to determine, it's up at the very top, two quantities are proportional. So we're looking at two quantities being proportional is we want to graph them, and then they have to have a straight line and it has to go through the origin. Then they are proportional. So if we get a straight line and it doesn't go through 0, 0, they are not proportional graphs. If we don't get a straight line at all, they're not proportional graphs. So in example 1, we have the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it's moving by graphing on the coordinate plane. So the first thing we get is we get this chart in step 1. So we're going to make a table to find the number of feet walked. They've done that for us. And this is just basically walking us through that process. Step 2 is to graph those ordered pairs. So we're graphing X, then Y, all the way up on the coordinate plane. And we can see that right here on this graph that I'm highlighting, we can see that it has the point 0, 0, and that is a strictly straight line. So the feet traveled, the number of feet traveled is proportional to the number of minutes. Okay, so let's do this next problem together. James earns $5 an hour babysitting. Determine whether the amount of money James earns for babysitting is proportional to the number of hours he babysits. Explain your reasoning in the work zone. So we are going to make our own table, obviously, and we are doing a rate of $5 per 1 hour of babysitting. So that's just like a coordinate pair, 5 for every 1. So the time is 1 hour. The amount of money he earns is $5. So we have like that 1 point right there at 1,5. So if he were to babysit for 2 hours, he would earn $10. So we can graph that at 210. If he were to babysit for 3 hours, he would earn $15. So we can graph that at 3, 15. So we have yet to graph a pair at 0, 0, but we would need to go backward per se. So if he did not babysit at all, he would earn $0. So if we graph that, obviously that line is passing through the origin because we have graphed the coordinate pair 0, 0. So it is proportional. For every 1 hour in time that he babysits, he earns $5 more per hour. All right, let's go down here to example number 2. The cost of renting a video game from Games Inc. is shown in the table. Determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane and explain your reasoning. So we can see they give us coordinate pairs of 1, 3, 2, 5, 3, 7, and 4, 9. So we write those as ordered pairs from that table first. We then graph those ordered pairs. So we end up with this graph right here. It is a straight line, it is linear, but it is not passing through that origin. You can see that it is at 0, 1. So the check is that the ratios are not constant, because we can look back in this chart and see those ratios. We can see that 3 times 2 is equal to 6, and 1 times 5 is equal to 5. And since 5 does not equal 6, they are not proportional. It's not going to go through the origin. Yes, does it look like it's proportional? Yes, because we have that linear line, but it has to go through point 0, 0. So let's take a look at this problem, letter B. The table shows the number of calories an athlete burns per minute of exercise. Determine whether the number of calories burned is proportional to the number of minutes by graphing on the coordinate plane. So those number of minutes and number of calories, we are going to make ordered pairs. So we have 0, 0, we have 1, 4, we have 2, 8, and we have 3, 13. Now automatically we can see that we're graphing a point on the origin. So that's one of the two things that our line has to have to be proportional. Then we are graphing at 1, 4, we are graphing at 2, 8, and we are graphing at 3, 13. So you can kind of see as we go, it's linear, 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 and then it kind of jumps up. That's a terrible line. Linear, jumps up, third time's a charm. Jumps up and it kind of curves there at the top, not quite as much as I made it. Goodness. But it would have to be at the point 3, 12 in order for it to stay strictly linear. So with this one, we would say it passes through the origin at 0, 0, but it's not linear because we don't have a proportional value at the bottom of our table. Because 3 times 8 is 24 and 2 times 13 is 26, we can automatically see why that is thrown off. All right, so if we go down to example 3, we can see there's already 2 lines on this graph. So which batting cage represents a proportional relationship between the number of pitches thrown and the cost? Explain. The graph for softball plus is a straight line, but it does not pass through the origin. So we can see here softball plus in green and blue. The graph for the fun center is a straight line through the origin, so the relationship between the number of pitches thrown and the cost is proportional. So we're just reading the graphs there. Remember, linear goes through the origin. All right, so now we're down to the guided practice. So we're going to do this. I want you guys to pause the video, and do this with a partner. So do guided practice 1, 2, and 3. And then once everybody, the majority of the class is done, you're going to come back and listen to me go through these. All right, so now you should have completed this with a partner, the guided practice. So let's take a look at number 1. The cost of a 3D movie is $12 for 1 ticket, $24 for 2 tickets, and $36 for 3. Determine whether the cost is proportional to the number of tickets by graphing on the coordinate plane and explain your reasoning. So we can say 1 ticket is 12, so we're graphing at 1, 12. 2 tickets were $24, 2, 24. And then 3 tickets were $36. Let me make these a little better. And then obviously if we bought no tickets, 0, we would not spend any money. So when we connect these points, they are linear. They are going through the origin. So your answer on the blank space should have been, these points are proportional cost to the amount of tickets because we have a linear line and we go through the point 0, 0. All right, number 2, the number of books to stories sell 1, 2, and 3 days is shown. Which book sale represents a proportional relationship between time and books? So if we look at both of them, it becomes very obvious that only one of the 2 lines, the book palace, is linear, and it does pass through the origin. So which is a proportional relationship? You would write on this line, the book palace. And if it asks you to tell the proportional relationship, you would say for every 1 day, you get 3 books. You can see that by reading the coordinate pair 1, 3. All right, last one when you're going to check for your partner work. Building on the essential question, how does graphing relationships help you determine whether the relationship is proportional or not? Remember, 2 big things. It needs to be linear, and it needs to go through the origin at 0, 0. If it meets just one of those things, it is not a proportional graph. All right, so by yourself, you are going to do the independent practice, which includes numbers 1, 2, 3, 4, 5. You're also going to do these hot problems and extra practice on your own. These 2 graphs right here are for the above numbers 11 and 12. We just made some bigger graphs for you. And then you can power up, do the test practice. So these would be things you're likely to see on your test with Spiral Review. So you have quite a bit of work on your own to do. So go ahead and get started on that. Keep that with you in your packet. And there's obviously no check in Canvas, but you can work on your weekly review when you are done with this. Just a reminder that on Friday, you will have a chapter quiz over this, and I will get you back your last chapter's quizzes tomorrow. See you guys tomorrow.